So Bertha has a bunch of daughters, and she has 6 daughters, and some of her daughters have 6 daughters as well, and the rest of them don't have any. So if Bertha has a total of 30 daughters and grandchildren and no great-granddaughters, we want to find how many of her daughters and granddaughters have no daughters. So Bertha has 6 daughters. So that means that she has 30 minus 6, or 24 granddaughters. And she doesn't have any great-granddaughters, so that means these 26 granddaughters don't have any daughters. But we also want to find out how many of Bertha's daughters don't have any daughters. So if there are 24 granddaughters and all of the daughters have 6 daughters each, then if we do 24 divided by 6, we can find that 4 daughters have daughters. So that means that, well, there are 6 total. There are 6 total daughters, and we subtract 4, and we'll get 2. So basically 2 daughters don't have daughters. And we'll add these 2 together, 24 plus 2, and that'll give us an answer of 26. Okay, so question 2, we want to find what y is, and the problem says that these hexagons, the L-shaped things, the hexagons can be repositioned so that they can form a square. And basically what it's saying is that it can be reformed so that it'll look like, oh, this is ugly, like this. Something like this. So in this picture, this is a square, by the way. In this picture, we know that this length is 8, and this is y, and this is also y, and this is 18. Oops, 18 minus y. So we want to know what this, let me change colors, what these 2 things are. And since both of these yellow lines are make up half of the length, the width, that means that it's just 8 divided by 2, or 4. So we know that this side is 4, this is also 4, and yeah. So from that, we can just see that the area of this square is 12 times 12, which is 144, and we actually didn't have to do that. And since it's a square, then we know that this side, 18 minus y, is equal to 12, and so we can solve for 12, and you'll get an answer of 6. Okay. Question 3. So we want to find what the ratio of the trapezoid FGIH, that's this thing. We're going to find the ratio of that is, okay, let me go back to the last question. So these things have to be half of this. because these hexagons are congruent, so that means they're the same exact thing. So these two blue things are the same exact thing. So if you put them together, you'll get 8, and that just means that one of the blue things is half of 8, which is 4. And the answer to this question was 6. So question 3, what is the ratio of the area of trapezoid? Yeah. First, we want to find the area of the trapezoid. And we know that AB, BD, DF, and FH are all equal. And basically, that just means that, AB is 1/4 of AH. So we can represent BC as Y, and since all of these triangles, you can't see that, all of these triangles, well, each triangle is basically 2 times the sine lengths of the smaller one. So basically, if BC is Y, then that means the next line, the next side, DE will be 2Y. And then FG will be 3Y, and HI will be 4Y. So now we can use this. Well, actually, let me draw the height first. We know that the heights are all equal. Like from this area, this line, this line, this line, this line, they're all equal. So we're going to call them X. And now we can represent trapezoid FGIH's area. So the area of that trapezoid is the base, the shorter base, which is 3Y, plus the longer base, which is 4Y, and then you divide it by 2. And then you multiply it by the height. And then we also want to know the area of the triangle AHI. That is going to be 1/2 times the base, which is 4Y, times the height. And that'll be 4X. So we want the area of trapezoid to triangle. So the area of the trapezoid will be on top, and it is 7YX2, and then the triangle is 16YX divided by 2. And we can see that our ratio is just 7/16. Okay, question 4. If the first term is 20, the sixth term is 220, what is the value of the seventh term? So we're going to call the second term 2x, third term will be 3x, and etc. So the third term, x3, will be equal to the sum of the 2 preceding terms, so x1 plus x2. And we know that x1 is 20, but we don't know what x2 is, and that's okay. So x4, the fourth term, is equal to x2 plus x3, and that will be equal to x2 plus this thing. 20 plus x2. So that is 20 plus 2x2. And then x5 is equal to x3 plus x4. And we just add these two together to get 40 plus 3x2. And then x6 is equal to x4 plus x5. And so that's just 6 equals 5x2. And we know that the sixth term is equal to 224. And now we can solve for x2. And we'll find that x2 is equal to 32. So now what we want is x7, the seventh term. And we know that x7 is equal to x2 plus x6. And we can denote that as 40 plus 3x2 plus this. So that is like well, we just actually need this. 40 plus 3x2 plus 224. And now we can substitute in our x2. So 40 plus 3 times 32 plus 224. And we can find that the seventh term will be equal to 3, 5, 6. That's your answer. Did I say something wrong? If I did, then I'm sorry. It was definitely 220. There is no 224. Okay, question 5. So I bought 4 different avocados, and then I also brought 3 identical bags. So we want to find how many ways there are for the cashier to put the avocados in the 3 bags. So we're going to use casework for this. So case 1 is when they're all in the same bag. And if they're all in the same bag, then there's only one way of doing this, since no matter what bag you put it in, well, all the bags are identical, so you can't tell them apart. So there's only one way. And then case 2 is when you have 3 in one bag and then 1 in another. 1 in another. So to do this, you just have to find which bag is empty, because no matter what bags the avocados are in, it doesn't really matter since all the bags are the same. So to find which one is going to be empty, you can do combinations. 4 choose 4, and that's equal to 4. And for case 3, you have 2 in one bag and then 2 in another. And to do this, you want to choose which avocados go in the first bag, and that's 4 choose 2. And then you have to divide it by 2 to correct for overcounting. And this will give you 3. Last case, case 4, running out of time, is 2 in one bag, 1 in another, and then 1 in another. And this one, you just have to choose which 2 avocados to put in that one bag. So you do 4 choose 2, which is 6. Then you add those all